All right. Now, in the last video, we went with one-step conversions, and they seemed like they were pretty simple. I left you with an example that you were supposed to work out. Hopefully you went ahead and did that, and that you completed the practice before moving on to this next one. Now, if you notice in this one, we still have a balanced equation, but we're asked about grams of stuff. So I start off with, just like we saw before, let's make sure I got my pen tool. Start off with 6.5 grams aluminum, and I'm asking how many grams of aluminum oxide are formed. Now, in your head, you're saying, okay, so Baldwin, you showed us this whole thing about the mole ratio. How does this fit? Well, we're going to bring in something that we already knew, and then we're going to add the mole ratio part in. What do I mean? Well, let's take a look at it. Since I'm starting with 6.5 grams of aluminum, so 6.50 grams Al, I need to get that into moles before I can worry about that whole mole ratio thing, right? Well, let's make my table. How do I get from grams to moles? I wonder. Have we seen this before? Well, 26.8. Oops, 98. Let's get rid of that. Let's try that again. So 26.98 grams aluminum. It's 1 mole aluminum. Okay, so if I were to stop here, I'd be in moles of just aluminum, right? This is where the mole ratio part comes in. You said it's moles you want over moles you have. Well, according to the question, the moles I want will be of aluminum oxide. And I get that number from here. So it says I'm supposed to get 2 moles Al2O3. And how many moles of aluminum do I put in? Well, 4. If I were to stop right here, I would be in moles of aluminum oxide. But it asked me to go to grams. So, last step, how do I get from moles of aluminum oxide into grams of aluminum oxide? Well, we need a molar mass, right? So 26.98 times 2, and plus the 3 oxygen. I just got a molar mass of 101.96 grams aluminum oxide and 1 mole aluminum oxide. So, if you notice at the beginning, we converted into moles of the substance, mole ratio, then out from moles into grams. Well, now that I have this long table, what do I do? Well, multiply above the line, divide what's below it. So 6.5, 26.98 times 2 divided by 4 times 101.96. And I come out with a final answer of 12.28 grams aluminum oxide. So this tells me if I started off with 6.5 grams of aluminum, I should come out with 12.8 grams of aluminum oxide. Pretty neat, right? Okay. Now, let's take a look at another example. So, we're given 10.1 grams of iron. Everybody should see that. Put into the copper sulfate solution, how many grams of solid copper will we get out? So I'm looking from iron all the way to copper here. Well, let's go through it. So, make my table, 10.1 grams Fe. And just like we did before, the first thing I need to do is get it into moles. Well, the molar mass, looking at my periodic table for iron, is 55.85. 1 mole of iron. Okay. Now, if I stop here, I've just been moles of iron. I need to get all the way to grams of copper. So, next step, mole ratio. Moles you want over moles you have. The moles I want are copper. So, 3 moles of copper for every 2 moles of iron. Okay. Again, if I were to stop here, Being moles copper, I need grams. So keep going. So what is my molar mass of copper? Well, periodic table says 63.55 grams. So made sure my units all canceled all the way through. Multiply what's above the line, divide what's below it. So 10.1 divided by 55.85 times 3 divided by 2 times 63.55. And I came out with the final answer of 17.24 grams copper. Now, my hope is that you're seeing that the process is really simple as long as you keep moving forward, okay? You have to keep the process going. Okay, curveball. Now, in your head, you're probably saying, Baldwin, why do we have to do this? Why do we have to throw this one in there? Well, it's still the same process. We're still going to start with a substance, one substance, and end with another. In this equation, you're given methane, which is going through combustion, producing carbon dioxide and water. They said you started off with 17.5 liters of oxygen. How much of your CH4 would you need? Well, make my table around my given. Now, if you remember, what was the conversion factor we needed for volume? Oh yeah, it was 1 mole is equal to 22.4 liters, right? Well, notice that in both cases we're dealing with liters. So this actually makes our life a little easy because we don't have to calculate anything first. So, take my conversion factor, 1 mole of O2, 22.4. Now to my mole ratio, moles you want over moles you have. I put 1 mole of CH4 methane, and I'm supposed to also put in 2 moles of O2. Okay. That would stop me in moles of CH4. I need liters. So, hey, my conversion factor comes back. But this time, 1 mole is on the bottom, and 22.4 is on the top. Do you notice something that seems to be almost exactly the same? Yeah. So it's basically going to end up being 17.5 divided by 2. Because if I multiply by this and divide by that, it cancels itself out. So 17.5 times, or divided by 2, is going to be 8.75 moles CH4. Oops, not moles, liters. Sorry about that. Don't want you guys having the wrong thing written down. Liters CH4. Much better. All right. Now, my hope is that you're starting to get the idea of how this whole thing works. We're still doing the same type of table, so we're going to set it up. We're still going to cancel our units like we're supposed to. And now we're just adding in that mole ratio step. This works for us whether we're doing 2 or 5 or 15 steps. As long as we keep the pattern going, we should be fine. That's where we'll pause for here, and then we'll look at the next video in just a minute. Have a lovely day.